Today I will be reminding you how to graph rational functions. So you need to be reminded of asymptotes and holes for rational graphs. Also remember that a rational graph looks something like this, 1 over x. So the asymptotes are the spots where you will never have that value. So for example, right here we have this where x equals 0. Our function can never be a 0 on the bottom here, otherwise it's undefined. And so this part right here, this up and down line where x equals 0 is undefined, we call that an asymptote. We have another asymptote right here where y equals 0 going straight across. We can never have this function equal 0 because 1 divided by something will always be something. So we also have an asymptote where y equals 0. In this case, there is no hole in the graph. It would be designated by a little point right here, which means that if we were to plug in a point right there, we'd also end up with undefined. So the asymptotes in an example like this, we would have x is 0. There's your asymptote. And also we'd have this line up here, which is y equals 3. So that's how asymptotes work. Whenever you're trying to find vertical asymptotes, we're looking for excluded values, values that do not work, or in other words, the domain of this function. Domain of this function would be x cannot be 2 because that's what makes this equal to 0. Right? We can't have the bottom equal to 0. So our excluded value, the value that doesn't work in here, the value that is not part of our domain, is 2. That is our asymptote. So instead of writing asymptote every time, you can just write VA for vertical asymptote, and that's where x equals 2. That'd be a line going down. From the graph we can see that y doesn't equal 0. So that would be another asymptote. It's called the horizontal asymptote, and we'll talk later about how to find those. Now again, we want to state the vertical asymptotes for this one. Vertical asymptotes come from the denominator. And remember, we can't have the denominator equal to 0. So we're going to have to factor this part. And hopefully you can see fairly quickly, need a number that multiplies to 2 and adds to 3. That would be a 1 and a 2, both positive. And then x squared is x and x. So the bottom factors to be x plus 1 and x plus 2. Now for these to be equal to 0, x plus 1 equals 0, so x would be negative 1. If x plus 2 is 0, then x would be negative 2. So these are both vertical asymptotes. When they become holes is when one of these factors cancels on the top with the exact same factor. So if there happened to be an x plus 2 on the top, x plus 2 would cancel with x plus 2. So this would be the x coordinate of a hole in that case. Find the vertical asymptotes. Again, we want to look at the denominator. Factor the denominator. 1 multiplies to negative 35 and has a difference of negative 2. We could have a positive 5 and a negative 7. So that means our vertical asymptotes are where x equals negative 5 or where x equals 7. Again, The factors on bottom do not cancel with the factor on top, thus there's no holes. Alright, here's another example with finding vertical asymptote. This time you'll notice that there will be a hole. When we factor the bottom, we said it was x plus 2 and x plus 1. But this time notice that x plus 1 on the top and x plus 1 on the bottom, these can cancel each other. This leaves us with 1 over x plus 2. So our vertical asymptote is negative 2. The hole for our rational graph would be from where we cross this out, which is negative 1. And to get the y-coordinate for this, we have to plug it in to the reduced form over here. So we'd say 1 over negative 1 plus 2, and that's 1. So we have a vertical asymptote where x equals negative 2, and we have a hole at negative 1, 1. Now for graphing this, we would draw our asymptote where x is negative 2. We'd have a hole at negative 1, 1. So right there is a hole. And it looks like the graph would come down through here and over here. Now we can always plug in numbers to check this to make sure that's how it works, but I'm guessing this is how it would work. So if I plugged in, say, a negative 3, I would get negative 1 as my answer, so it does come down through here. Okay. We'll talk more on how to graph these after we find horizontal asymptotes as well and intercepts. So here's another example. We want to find the holes and the vertical asymptotes. The denominator we can factor to be x plus 2 and x plus 3. That's two numbers that multiply to 6 and add to 5. On the top, we can take out a greatest common factor of negative 2, and that leaves us with x plus 2. So notice our x plus 2's are going to cancel, and that leaves us with a negative 2 on top and an x plus 3 on bottom. Which means our vertical asymptote is where x equals negative 3. And we have a hole with an x coordinate of negative 2 from the one we crossed out. To find the y coordinate, we plug negative 2 into the reduced version of our function. And that would give us negative 2. Alright, one last example with holes and vertical asymptotes. Just a quick reminder of how to factor when there's a leading coefficient. Most of the time we'll factor by grouping. So in the grouping method, you multiply the first number and the last number. You find the factors of that will add to the middle number. So 1 plus 6 is 7. We're going to split the 7 to be 1x and 6x. We still have the first term and the last term. Now you group the first two terms and the last two terms. Pull out the greatest common factor for the first term, which is x. You're left with 2x plus 1. Out of the second two terms, you pull out greatest common factor of positive 3, and you're left with 2x plus 1. Parentheses are the same, so that's 2x plus 1, and you're left with x plus 3. So notice that 2x plus 1, x plus 3, they're not the same as the factor on top, which means they're both vertical asymptotes. So out of this second case, that's easy, it's negative 3. Out of this other case, 2x plus 1 equals 0, you would subtract the 1 and divide by the 2. So you get that x is negative 1/2. So we have two vertical asymptotes at negative 3 and negative 1/2.